In the last video, we used a pin change interrupt to detect whether a switch was pressed or not. Now, the main benefit of using interrupts as opposed to polling a pin is, well, you're not keeping the processor occupied just with one particular task, but besides that, you're actually able to put the processor down to low power sleep modes and reduce dramatically the power consumption of an application. This is particularly important for battery-driven applications and the like. Now, low power is really one of Atmel's core technologies, and if you have a look on their website, you'll find some design examples and a series of videos covering low power techniques, and also a very good application note about the basics of low power. I'm going to implement some of these things in this video now. So if we take our example application, we're detecting a switch being pressed in a pin change interrupt. So let's have a look at the data sheet and see. Well, notice first of all that the power consumption at 1 megahertz is 200 microamps or 0.2 milliamps. That is what you would use per megahertz. Notice that that's at 1.8 volts. Also notice that power down mode is as little as 100 nanoamps. So let's see if we can use power down mode. So clicking on the power management and sleep modes, there's a table where we can see which peripherals are available to us in which power mode. So the pin change interrupt, we can use all the different power modes, and as we said before, we want to use the power down mode. Okay, the other thing that I want to talk about is the power reduction register. Now, this provides a way to stop the clock to individual peripherals to reduce the power consumption. So you turn off everything that you're not using. So I see the power reduction register, and so what we're wanting to do is, as part of our initialization, we're wanting to write to the power reduction register and actually just turn everything off. You can see that none of the peripherals listed here are actually being used in our application. So let's look at AVR Lib C and see what support they have for sleep modes. Okay, so AVR sleep, so that's our header file which we're going to add. Okay. So the simplest way is to set the sleep mode. So we got to set sleep mode and then actually call the sleep mode command when we want to put the processor to sleep. So set sleep mode, we've got to send a parameter to this. One way we could find this is, so this is all grayed out for processors which are not relevant, so we can just look for the one relevant to us and we can see, okay, so we wanted power down mode. And all that's left for us to do now is call the sleep mode. And you can see that sleep mode actually does a couple of things. It enables sleep, puts the CPU to sleep, and then disables sleep when the processor wakes up. Okay, so let's run. And you can see we still have the same functionality in our program, but much lower sleep. So I recommend having a look at the following application note, AVR 4013, which covers many of these concepts in a lot more detail. Thank you.